In this video, we'll be looking into the software testing subject and we'll be dealing about the first module, important questions or topics to cover. So firstly, we have definitions. So these definitions could be asked for 1 mark each. So they can give 5 or 10 terms and they'll be like define the following anta kelbodu. So starting from the first point, that is first terminology, that is error. So error is also called as bug. So it occurs while writing the program. So because of error, a fault occurs or defect occurs. So fault or defect is the representation and result of error. So fault could be further classified into two types, that is fault of commission and fault of omission. Fault of commission means this will occur when like any wrong action happens. Fault of commission happens. Fault of commission occurs. Fault of omission is like suppose a particular action was supposed to happen, but then failing of that could lead to like missing that particular step and then moving on further. Omitting it also, omitting that particular part is fault of omission. Next we have failure. So failure is a faulty piece of code. Like when this code gets executed, it leads to incorrect state. Then we have reliability. So reliability is probability of failure-free operation. Then we have test. So test is the action of performing the software with test cases. Then we have usability. Usability speaks of the ease with which application can be used. So if the application runs as expected, then it means that the usability status of that particular software is high. So as expected, performance, safety and security should be maintained. So if all these things are maintained by the software, then it is considered as usable and correct also. So correctness is a program considered correct if it behaves as desired on all possible test cases. So we test with all the possible test cases and check if the desired output is received or obtained or not. Then we have performance. Performance refers to the time the application takes to perform a requested task. So lower the time, the higher would be the efficiency of that particular application. Along with this, we also have topics like what is test suite, what is test design. So test suite is like a set of cases for a particular testing, like we have a particular testing objective. So in order to test a triangle problem, we'll write all the possible test cases, right? We'll consider that as a test suite. Then we have the test design. So test design is the construction of test suites. Then we have like the diagram for how error, like firstly we have the error. From error, we'll get the faults, and from fault, failure occurs. So this is how the flow of errors is. Moving on further, next topic we have is the definition of ST. And yeah, so we have definition of ST. So software testing is a process to evaluate the working of application software with intent to find whether the developed software met the specified requirement or not. So here we are ensuring that the expected output or the expected requirements are met by our developed software. And we also try to identify the defects to ensure that the production is defect free in order to provide and produce quality product. So our main motto is to provide a quality product, and to do that, we'll be performing testing. Yeah, so software quality is pretty crucial. So measures of software quality are, so firstly we have is the correctness. Correctness is again according to specification and requirement if it meets or not. Then we have reliability, that is probability of failure-free operation. Then we have completeness. Completeness is once executed, all features should implement functionally, all features should work properly. Then we have consistency. Consistency is like it has to adherence to common set of convention and assumptions. So that is, it has to like be parallel with the expected output. Okay, so if the expected output and obtained output are same, then we can say that our program is considered to be consistent. Then we have usability. Usability is the ease at which we can use that particular application. Then we have performance. Performance, again, as we discussed, it is the time taken for an application to complete a particular task. So this was about the software testing and how to check the software quality. So in software quality also we have two types, that is the quality attributes. In quality attributes we have static quality attributes and dynamic quality attributes. So all these they come under dynamic quality attributes. Whereas speaking of static quality attributes, they look into the actual code part, that is it could be the structure or it could be the like what are we providing the test cases and all of that. So moving on further, we have is the test and debug cycle. So test and debug cycle is a pretty important topic. This could be asked for 10 marks, guys. So I would suggest you to cover this topic. thoroughly and go through the points. Okay, so starting from this part, first we have the input domain. So from the input domain, from the input metadata, certain input data would be taken. From that data, we'll construct the test input. So this test input would be utilized to create the operational profile. Then along with that, we also deduce the test plan here. Test plan is the plan through which our execution of test cases happen. So after this, we'll derive one by one test case. Taking the first test case, we'll execute it with the program. So when we execute it with the program, we get a behavior output. Right. So is this behavior expected? Was it similar to the expected output? So if we see the yes part, yes, the behavior was same. That is testing to be terminated. Here again, we have two options. Either to not terminate and then repeat the same thing, or yes and file the test session report. So we are forming this test session report in order to give like a report to the user, to the programmer, that your program on so and so test case has worked properly. In case if the behavior is not same, we'll look into this part, that is cause of error to be determined now. So we'll check what is the cause of error occurring. So meanwhile, we'll also debug the program and then find the error to be fixed. Now we'll check if the error could be fixed. So this debugging of program obeys the test plan. Okay, so we'll go according to the test plan here. So the behavior is expected or not, we'll be updating the specification also here, because on each time when we get a particular output, a particular behavior, that has to be recorded and further used for this comparison purpose. Then here, error to be fixed now. So fix the error, we have two options, either to fix the error or file pending error report, or file pending error report and then get it back to this stage, that is testing to be terminated or not. So this is how the cycle continues. So here initially we are testing, and on this part we'll be looking into the debugging aspect of our program. So looking at the points, what to write. So firstly, we have the input domain and the test case construction. So from the input domain, we are taking a certain set of inputs and considering them as the input data. And from that input data, we'll be generating the test case, obeying the test plan. Then further, we'll move on to the execution of test plan and program. So in this stage, the execution of the test cases happen. So after the execution, we get the behavior of the program. So next we have third, that is analyzing the behavior. So in analyzing the behavior, we'll check if the obtained behavior is same as the expected behavior or not. If the behavior is same, we'll move further, checking if we have to terminate the program or not. If not, we'll look into finding the cause of the error and debugging it. Okay. That was about this. Next we have error handling and debugging the program. So in this stage, we'll be looking into the errors which have occurred, and we'll be dealing about debugging the program accordingly. So debugging, there are further many methods. We'll be studying it further. So when testing reveals an error, so this process, the process used to determine the cause of this error and to remove it is called as debugging. And testing is like the process of determining if a program has any errors or not. Next, moving on further, fixing the errors. So here we try to fix the errors by finding the cause of error here, and then we find the cause of error and then fix it. Okay, that's what debugging speaks of, right? Then we have reporting and termination. So once the debugging is done, we have to file a test session report, and along with that, if the debugging has not happened successfully, we have to file a pending error report. So documentation is pretty necessary, because like it will help us to trace through the errors which have occurred, and in future we can come up with possible solutions. Then we have the specification update. In specification update, we'll give the update regarding the specifications of that particular software. These specifications could be related to the input or the functions which have been used, or any other characteristics. So this was about testing and debugging cycle. Along with this, if they ask what is testing, what is debugging, explain them with a appropriate diagram anta kelidre, we have to draw this diagram and explain. Okay. Next, moving on further, we have the definition of static testing, what is walkthrough and inspection. So understanding static testing. Static testing is evaluating the quality of software product without executing the code. So we need not execute the code as such. Without doing that also, we can perform testing on the code. That is what static testing speaks of. So this involves only reviewing and analyzing the software artifacts like requirements, design document, source code, and so on. So this was about static testing. In static testing, we have two common techniques. First one is the walkthrough, and along with walkthrough, we have inspection. So looking at walkthrough, it is an informal process. So in this, our all focus is to ensure that all understand the content and the intent of artifact being reviewed. So it is a collaborative discussion. It does not follow a predefined checklist for or formal process. It is conducted in early stage of development. It is like informal discussion among your teammates. You just sit together, speak of the requirements, what is the content, and what are the artifacts being reviewed. All that you'll be looking on it. So there is no like proper strategy or the goal or agenda of your meeting. You just sit and discuss it informally. Coming to inspection, inspection is opposite to that. That is, it is a formal practice process. So here we have the systematic execution by team of reviewers. So team of reviewers could be could comprise of all the developers, testers and all. So here specific roles are allotted to each and every person sitting there. So it could be a moderator, author or reviewer, or the main manager, or anyone for that matter. Next, inspection has the checklist and guidelines to be followed. That is, as we discussed it as a formal process. So it has to adhere to all the necessary conditions, right? All the proper guidelines should be followed. So inspection focused on defect identification. Here our focus was to identify what is it about our software. But then when it comes to inspection, we'll be identifying what are the defects, and we'll have a formal meeting which happens and then used for critical artifacts. So we'll identify what are the defects happening, and we'll come up with a plan on how to deal with it further. So this was about static testing, walkthrough and inspection. So this could be asked for 5 marks, guys. So make sure you understand this properly. Next, moving on, this is the most important topic of first module, I would say. That is functional testing and structural testing, or it is also called as black box testing or white box testing. So starting with functional testing, it is also called as black box testing. All the focus is to evaluate the software against the requirements. So here we are not getting into the technicalities of the software. We are just looking at the requirements. Okay, just the input part, output part, that's it. We need not look into the what is the code, how is it written, what are the methods being used and all of that. So test cases are derived from requirements and specifications. So from these external factors only our test cases would also be generated. Next, we have the types. So in types, we have unit testing, integration testing, system testing, and acceptance testing. So all these are dependent only on, all these are a part of functional testing, and the test cases for these are dependent on the requirements and specifications. We need not look into the code here. Next, implementation is not known, only input output is used, as we have discussed. Coming to structural testing, it is white box testing. White box testing, by definition, we can understand that everything is transparent here. That is, our focus is to evaluate the code, logic and structure. We can get into what is the code logic, what is the structure of code, what functions have been used, what is the data structure which is being accessed, and all of that. So structural testing is derived from internal code, and we use this knowledge to perform testing. So in this we have statement, branch and path testing or covering. So all these come under white box testing. Okay. Next, implementation is known and used to identify the test cases. So previously the test cases were identified from the requirements here, but then here the test cases are identified by keeping knowledge of the internal code. Okay. Next, we have the advantages. So here advantages is independent of software, and the test cases can occur parallelly. The test case development can occur parallelly. Coming to the white box testing advantages, they use the test coverage matrices. Coming to disadvantages of black box testing, redundancies may exist here because we are just considering the output input aspect. That's it, right? We are not going in depth of the program. And then we have possibility of gap for untested software. There could be corners where our input output cases may not cover that. No. So in such cases, this is a drawback. So looking at the diagram here, so here we have the specification, here we have the program. So among specification and program, let me draw it here. This is specification and this is program. So as we know that our black box testing is related to dependent on the specifications, we can draw like this. That is, the test cases would be dependent on specifications. Speaking of the white box testing, in case of white box testing, we can draw on the opposite side, that is in the program side. Here we know the test cases, we know what is the code and all of that. So we can look into the program aspect of our code. Okay, so this was about the differences between functional testing and structural testing. So again, even if they ask for 5 marks also, make sure that you draw those diagrams properly, properly write the differences. Moving on further, we have test metric. So test metric is a quantitative measure used to access various aspects of software testing. So the processes include effectiveness, progress, quality, and efficiency. So test metric provide objective insights into testing activities. So it allows us to track the performance, make data-driven decisions. So there are 4 general core areas that assist in designing the test metrics. So those 4 metrics are schedule, quality, resources, and size related metrics. We'll look into 2 of them. Rest 2 of them you can just we'll look into 4 of them, all 4 of them. Okay, first one is we have schedule metrics. So its focus is on tracking and managing the progress of software development activities according to the predefined timeline and milestones. So depending on the schedule, depending on the timeline or the milestone, you have to complete this particular work. So by making use of those time as a constraint, we'll derive these matrices. So firstly, we have the time to market. Time to market will tell that the time taken from start to release of final product. Then we have schedule variance, that is compared to the total compared plan versus actual schedule. So compared to what you had planned and what is the actual schedule of your project, we can make use of this matrix, that is schedule variance. Then we have the lead time. Lead time is the time taken to complete specific tasks within a development process. So schedule metrics help us in ensuring that the project progress according to the planned timeline, identifying the potential delays and making adjustment to meet the deadline. So if we have deadline or predefined timelines, it becomes easy for the team to identify where they are lacking behind and work accordingly to meet the deadlines. This was about schedule matrices. Next we have is the quality matrices. Quality matrices focus on assessing the quality, reliability, performance, usability, and security of the software. So this helps in monitoring and improving the overall quality, ensuring that it meets the expectations, the expectations of users and requirements provided by the stakeholder. Looking at the examples, we have defect density, that is number of defect identified per unit code. Then we have defect removal efficiency. Defect removal efficiency means the efficiency of defect removal during the testing. How efficient are we to remove the errors or defects? It could be 10%, 15%, and so on. Then we have the customer satisfaction. Customer satisfaction, it provides a scale to measure the satisfaction level of the end customer. So this was about quality matrices. Speaking of resource matrices, we'll be dealing, our main focus would be on the resources. That is, what are the resources being accessed and is proper output being generated or not. One thing we have to make sure is to optimize the resources, be it time, people invested in the project, or what are the other resources also. So looking at the examples here, resource utilization, that is to make sure that all the resources are being utilized properly, or optimal usage of resources can also be written here. Then we have cost variance. Cost variance is the amount of resources which you are using and what is the cost, you have been allotted a particular budget, right? So you have to make sure that you don't exceed the budget. Okay, so and win-win condition should be satisfied or should be obeyed for the stakeholder as well as the the company, the developers. Then we have staffing levels. Staffing levels are again a parameter to make sure that the resources are being used optimally. Then we have the size matrices. Size matrices is it speaks of the size of the program which we have written, the physical size. Okay, how many lines have we used? How many lines have we used, or what are the functions which are being used, or what are the resources being accessed here, and all of that. So all these 4 points come under the test matrices. If they ask about test matrices, make sure you cover all these points. Moving on further, we have in this test matrices we have organizational metrics, project metrics, and process metrics also. So looking at organizational metrics, so these metrics at organizational level are useful in overall project planning and management. So it allows the senior management to manage overall strength. So it also helps us to set new goals for our project, for our team, and plan accordingly for the resources. Then we have the project metrics. So project metrics are related to specific project. So it might vary from project to project. So examples for this is IO device testing or compiler design testing and so on. So project metrics speaks of the ratio of actual to planned system test effort in one project metric. So it also speaks of ratio of number of successful tests to the total number of tests which are being performed. Then we have the last, that is process metrics. Process metrics is used to evaluate the process. So right from the start of project to the ending of project, are we able to deliver the software product or not is what we'll be assessing here. So our goal is to assess goodness of the project. So during each phase, we perform unit testing, integration testing, and system testing. So this comes under project metrics only, because at each stage we're performing different sorts of testing, right? Yeah. Then we have our main motto under project metrics is to monitor the progress. So this was about the test matrices. Let's move further. We have measuring the software quality. So again, this is again an important topic. What are the means of measuring software quality? There are two main factors. One is the correctness and reliability. So it could be asked for 5 marks or 10 marks. Sorry, it could be asked for 5 marks only. So speaking of measuring software quality, it involves assessing various attributes and characteristics of software to ensure that it meets the requirements and expectations of stakeholders. So here in this software quality testing measuring, we have two aspects. One is the correctness and one is the reliability. So you might think correctness and reliability are almost same. Yeah, they are almost same, but then there are slight variations of each of them. Let's look into them one by one. First we have is correctness. Correctness speaks of the degree to which software behaves according to the specifications. Yeah, we have seen this definition in the previous page also. Then we have correctness. Correct software is intended to function accurately and consistently under various conditions. So if the software is proper, it will work under any sort of condition, right? So correctness involves ensuring that the software produces expected output for all possible inputs and scenarios. So method for measuring the correctness is requirement verification, testing, code review, and static analysis. So our main motto under correctness is the program should be error free, and we make use of binary metrics. So either it is 0 or 1. So if it is 0, we can say that it is not correct. If it is 1, we can say that our software is correct. So it could be correct or incorrect. That's what I have explained here. Next, moving on to the next aspect, that is reliability. So reliability is ability of software to perform functions consistently over time and under any conditions. So over time, when we are checking the software functions and performing test cases under various conditions, it results to reliability. So reliability of a program is probability of its successful execution on randomly selected element. So it is a continuous metric, but speaking of correctness, it was a binary metric. So here the scale is from 0 to 1. Here the possible combinations are 0, 0, -1 and 1, -1. Then we have the methods for measuring reliability. It could be failure analysis, or it could be fault tolerance testing, stress testing, or available analysis. This was about measuring the software quality. Again, this is an important topic, guys. Moving on further, we'll look into what program behavior is. So program behavior refers to how software program responds to different inputs and conditions during execution. So we can explain program behavior by using a Venn diagram. So that is, a Venn diagram is a useful tool for depicting the relationship between different aspects of program behavior. So the key components of Venn diagram are specification, program, and test case. So here we have the specification, here we have the program. So considering this diagram, we have specifications here, program here, and test cases here. From this particular diagram, we can explain 3 or 4 points further. That is, firstly, we have the correct portion. Correct portion andre the program is executing properly. So the software is responding properly to all sorts of inputs. It comes under 1. Okay, correct portion. Then we have 7 and 2, that comes under specification, 8 and 6 under program, and 9, which is not being tested at all. Speaking of 7 and 2, that is fault of omission, that is missing functionality. Here we are not including the program, right? So fault of omission. Then we have 8 and 6. 8 and 6 are extra functionality, that is fault of commission. Coming to 1, which is a correct program. So this was about program behavior, or explain program behavior using Venn diagram. Next, moving on further, They can ask us to elaborate on the human errors in testing. Human errors in testing could be of various types. So here I've noted it down. First one is misinterpretation of requirements. So the stakeholder must have told something, I understood something else, and because of that errors could occur. Then we have incomplete test coverage. So not testing the particular software to its complete extent can lead to incompleteness. So this could again lead to errors. Then we have ambiguous test cases. When the test cases are of same type or there's no difference at all, it could lead to ambiguity. Then we have the data entry errors. So while entering the test case, I had to enter 3-4, I entered 4-3. Again, it's a data entry error. We have copy paste errors. I am copying something from the net, instead of pasting it on one column, I've pasted it on the other column. Again, error occurs. Then we have incorrect assumption. So again, misinterpretation of requirements or miscommunication between the stakeholder and the developer leads to incorrect assumptions. Then we have lack of attention to the detail. So during the requirement analysis or elicitation of requirements and all of those, if the software team or the developers team are not paying attention to the details, it might again lead to errors. Then we have confrontation bias. Confrontation bias again could be a possible human error. Then we have the types of faults. We'll be looking into types of faults further. Majorly, they are classified as input fault, output fault, logic faults, computation faults, data faults, and interface faults. Next, moving on further, in test cases, this question is like related to identifying the test cases with respect to black box testing and white box testing. How will you identify which test case to derive? Anta, they have asked. Okay, so in software testing, test cases are designed to verify the functionality and behavior of software system. So the approach is to identify the test cases differ between black box and white box testing. Let's look into them one by one. Firstly, we look into black box testing. So these are derived based on the external behavior. Yes, the input output we have discussed, right? So without knowledge of internal implementation. Our focus is on testing the functionality and features of software from end user's view. So here the tester can be considered as an end user because he has no knowledge about the internal code or the structure of the program, right? So this testing is done from the end user's perspective. How will we identify the test cases? We'll identify the test cases by requirement analysis, equivalence partitioning. How will we perform testing? Anta, they have specified here requirement analysis. From requirement analysis, we can do equivalence partitioning, boundary value analysis, use case scenarios could be used, and then error guessing can also be done. Looking at an example here, consider simple web application logic feature. Requirement is user should be able to log in with username and password. So here test cases generated could be to verify that the user can log in successfully with valid username and password. This is one test case. Next test case could be error message. Either the username is invalid or the password is invalid. Next test case could be after 3 attempts, the user window, the login window could freeze and the person may not be able to log in further. Moving on to the white box testing. So test cases are derived based on the internal logic and structure and implementation of the code. So testers have access to the source code and design details of the program. So they design to deal test cases that check specific paths, conditions, and branches within the code. So here we have condition analysis, code analysis, in which we have the control flow and data flow analysis. Along with that, we also have branch path analysis and coverage. So looking at the examples, let's consider the same scenario, that is a user should be able to log in with username and password. Now let's see what are the possible test cases we can derive. So the first one is verify that the correct credentials are validated by login function. Once the user gives a valid function, they have to be checked on the back end, right? So that is one of the test case. Second test case is error message, username is blank or password is blank. When username is blank, password is blank, what to do is what we'll deal here. Then we have system log successful, unsuccessful within a particular attempt. So that was about identification of test cases for white box testing and black box testing. Moving on further, we have the programs, the 3 or 4 important programs from first module. First one we have is traditional implementation of the triangle problem. So here we have the triangle problem. So there are 3 inputs, 3 sides of triangle. So here we should the triangle property should be satisfied. That is, A is less than B plus C, B is less than A plus C, C is less than A plus B. Considering this as the 4th condition, our first condition is all A, B, C should be between limit 1 to 100. Here the range could vary depending on the user. Next, our first condition is if all three sides are equal, then it is equilateral. One pair of sides are equal, then it is isosceles. No pair is equal, then it is scalene. And if the fourth condition fails, that is the triangle property fails, then it comes under not a triangle. The output which should be generated is firstly whether it is a triangle or not. If it is not a triangle, then directly give not a triangle. If it is a triangle, print scalene, equilateral or isosceles. So looking at the traditional implementation, in exam they can ask either the traditional implementation or the structured implementation. We'll look into both of them. So firstly we have the traditional implementation. So dimensions ABC match as integer, ABC are taken as integers. Then output is you're printing here. Output andre you're printing, input andre your scanf. Okay, so to make it easy for understanding, I've written here like this. It could be, it has to be expanded and written. Okay, output, input anta. So we have output as 3 integers of 3 sides. Then input is we are scanning 3 values ABC, and again we are printing side A is this, side B is this, side C is this. Then we are initially taking match as 0. Initially we'll take match as 0. So I'll take match as 0. So I am here. I took the input ABC and I took match as 0. Next, if A is equal to B, then match is equal to match plus 1. If A is equal to B, yes, if it satisfies, then match is equal to match plus 1. End if, done. Next we have A is equal to C. If A is equal to C, match is equal to match plus 2. Match will increment. Then we have B. If B is equal to C, match is match plus 3. If all these 3 are satisfied, next we'll look into this one by one. Each condition match each. We'll look into each condition of match. Okay. So starting from match is equal to 0. If match is equal to 0, we have 2 possibilities here. That is, then if A plus B is less than equal to C. If A plus B is less than equal to C, then it is not a triangle. If A plus B is less than equal to C, if it is obeying the condition, it means that it is not a proper triangle, because A should be less than B plus C, right? This is wrong. Okay. So if this condition is satisfied, it will come to not a triangle. Done. We are done till this part. Next, else if A plus C is less than equal to B, A plus C is less than equal to B, again if it is true, it is not a triangle. Again B plus C is less than equal to A, again if it is true, it is not a triangle, it will come here. If all these fail, it comes under scalene condition. If all these fail, it comes under scalene condition. So we are done with till here. Okay, till here we are done. Now I'll take match is equal to 1. When I take match is equal to 1, I'll come on this side. Match is equal to 1 here. If A plus B is less than C, less than equal to C. If A plus B is less than equal to C, I came here. If this condition satisfies, then it is not a triangle. I came to not a triangle here. Yes. If it fails, then it is isosceles. I came to isosceles. End if. This part is ended. Next, I'll move on to the other side. That is else if match is equal to 2. That if match is not equal to 1, I'll jump into match is equal to 2. Checking if match is equal to 2. If match is 2, if this condition is true, I'll look into A plus C is less than equal to B. A plus C less than equal to B. If this is true, then it is not a triangle, because it is not obeying the triangle property. If it fails, then it comes under isosceles condition. Here it came under isosceles condition in no part. Right. I'm done with match is equal to 2. End. Next I came to match is equal to 3. In match is equal to 3, if B plus C is less than equal to A, if this condition is satisfied, then again it is not a triangle. Again it is not a triangle. Else it is isosceles. Else it is isosceles. Not a triangle. I went here. Not at, else it came to isosceles. If all this fails, we can say that our main core condition, which was A is less than B plus C, B is less than A plus C, and C is less than A plus B, is satisfied, and we ultimately come to this particular point, that is else output is equilateral. So we are printing that our triangle is equilateral. So this was the traditional implementation of a triangle problem. It is also called as Fortin version. Looking at the structural implementation, either they could ask the triangle implementation, the traditional implementation, or structural implementation. Looking at the structural one, we have structural implementation. For that we need to write the code first. So structural program version of simpler specification. So here I'm taking dimensions as ABC as integer, followed by that is triangle condition. I'm taking it as boolean, yes or no. First step, I get input A, B, C. I'm taking as input. Here output input code anta keltidare illi. A, B, C I took input. Then output I'm printing. Side A is A. It obeys the same for B and C. Side B is B. Side C is C. Next, after taking the input, I'll check if it is a triangle or not. That is, we'll write this triangle condition. If A is less than B plus C and B is less than A plus C and C is less than A plus B. If this satisfies, then we can print that is triangle is true. This being a boolean function, it will result to true, else it will come as false, and we are ending the if part. Second step is also done. Now we checked if it is a triangle or not. Now when we get it as a triangle, we will look into what sort of triangle it is. So we'll come into this part, that is, if A is equal to B and B is equal to C, we can say that all the three sides are equal. It will come under equilateral triangle. If A is not equal to B and A is not equal to C and B is not equal to C, it comes under scalene condition. If this fails, either two sides are equal, we come under isosceles condition. And ultimately, I am ending all the parts. And output I'll give, if all this fail, no, I'll give it is not a triangle. Anta. Looking at the structural implementation here, it is pretty easy. The data flow diagram is pretty easy compared to the traditional implementation. So from keyboard, triangle inputs are taken. Here we have the triangle program, and here we have the prompts and triangle types, and the output is given. So taking the triangle sides here, we take the input A, B, C. I took the input. Now I'll check if it is a triangle or not. If this is true, we'll come up to this side. And here also we are giving input A, B, C. We have given A, B, C. And it is true. It is a triangle. Then we'll check what sort of triangle it is. So this was about the triangle problem. We'll move further. We'll look into the next date function. Now let's look into next date function. So for next date function, they can ask the pseudo code. Here again, we have two types of code here. First one being the simpler code, and the other one is the improvised one. So starting with the simpler one, the next day function or the next day problem speaks of like we take an input comprising of the date, month and year, and we have to generate the next date of that particular input. So starting from this, we have specified the three conditions, that is, month should be between 1 and 12. Date should be between 1 and 31, and year should be between 1812 to 2019. So starting from the initialization, so firstly we are taking the tomorrow day, tomorrow month and tomorrow year as integer. Followed by that we have date, month, year as integer. So date, month, year are the integers, and we'll be printing as enter today's date in the format of month, date and year. So this format could be specified by us. So depending on if we want date, month and year, even that could be done. After specifying the output, we are taking the input now. So the input again comprises of month, date and year. Now we'll look into the month case. Okay. So depending on the number of days present in the month, our next date function will also vary. So starting from the month, case 1 is month is 1, 3, 5, 7, 8 or 10. This means that there are 31 days in month. So if you see Jan, March, and all these other months have 31 days, right? So except December, because December has the separate case. We'll look into it further. So if D is less than 31, so if D is less than 31, I'll be updating tomorrow day value, that is TD is equal to day plus 1, else I'll be taking it as D is equal to 1. That is, if it is not less than 31, if it is 31, then I'll take next day. That is, we'll get into the next month, right? So if I'm taking 31st Jan, I have to find the next date. It will be 1st Feb, right? That is, month will get incremented. T of M is equal to M plus 1. We'll end this condition and move on to the second condition. That is, if month is 4, 6, 9 and 11. 4, 6, 9 and 11 says that there are 30 days in month. So looking at this further, so if the day is less than 30, then we can increment the day and keep the month as it is. Else we can increment the day, we can take the day as 1 and month as M plus 1. So in case of April, we can say that if I've taken 30 April, then the next date would be 1st of May. M value will get incremented. This was about the 30 days and 31 days. Now let's look into the exceptions part. So back then we didn't consider 31 days. That is, December also had 31 days, but then we didn't consider December. We'll look into it as a separate case now. So if D is less than 31, then D would get incremented. Else, if it is 31st of December, we'll get into the new year, right? So that is T of D is equal to 1, T of M is equal to 1. And now, if y is equal to 2019, we have to give output as 2019 is a boundary year, so we cannot increment further. Then this was condition for this part. With these two execution, even the else part would get executed. That is, T of y is equal to y plus 1. The year would also get incremented. Then we are ending this part. Next, moving on to if month is equal to 2. Month is equal to 2 under February. February has two cases. One, if the year is a leap year, then we have 29, and if the year is not a leap year, then we have 28 days. That is, if D is less than 28, then we'll increment then we'll increment the tomorrow day as d plus 1. If d is 28, then we can print as it is if d is 28, again we'll check one condition, if y is a leap year. If it's a leap year, then we can take t of d as 29. Else we have to take t of d as 1 and month as March, that is 3. And after that we'll check if d is equal to 29. If d is equal to 29, we can take that t of d is 1 and t of m is 1. Then we'll print it as this is not possible in February anta. So finally, after ending the end if loops, once here and one here. So ending these three if parts, we'll get end if into 3 times. Followed by that, we'll write output is equal to tomorrow date, tomorrow month, tomorrow date, and tomorrow year. And after that, we'll exit the next date function. So this was about next date function. This the pseudocode of next date function could be asked. And one thing to remember is that make sure that you remember all the 4 cases properly. Inside cases you can like alter it. It may not be t day or tomorrow date. You can take any other variable or perform minute changes also. Next, moving on further, we have commission problem. Again, commission problem will be studying this thoroughly in data flow testing 3rd module, 2nd module and all. But as of this module, this is not that important. But then, yeah, having a vague understanding of how commission problem is, what is the problem statement, will help us to write. If at all it appears in the paper, we can write it. Okay. So understanding the problem statement, that is, we have a salesman who has who creates a rifle. So he has lock, stock and barrel as parts of the rifle. So the costing is lock price is 45, stock price is 30 and barrel price is 25. So he has to sell at least 1 complete rifle per month. And the production limits are the total locks could be 70, total stocks could be 80 and total barrels could be 90. So moving further, we have the commission part. So if a person sells total lock, stock and barrel, then we'll calculate the commission. So we'll calculate the sales, that is total sales for the lock, sales for the lock, stock and barrel. Then we have commission. So in commission, we'll calculate the commission. So the like 10% up to commission if it is up to 1,000 or including $1,000. If it's beyond, if it's next 800, no, we'll calculate 15% of it. And if it exceeds 1,800, we'll calculate the 20% as commission. So looking at the problem here, we are taking program commission, input output. So specifying the lock, stock, barrel, total lock, total stock and total barrel as integers. Followed by that, we are taking the lock price, stock price and barrel price, lock sales, stock sales and barrel sales as real numbers. Then we are taking the sales and commission as real numbers. So initializing the lock, stock, barrel values firstly, and along with that total lock, stock, barrels would be 0 initially. Then we'll start. Then we'll take the input of lock first. So we'll take the input of lock and we should make sure that the lock value is not -1. If the lock value is -1, then it is like we reach the end of the execution. Okay. So making sure that lock value is not -1, we'll look further. That is, we'll take stock and barrel also input. So after taking stock and barrel as input, we'll update the total lock, total stock and total barrel here. Lock, stock and barrel values are updated. Again, I'll take lock value and check if it keeps on iterating, no, till this condition fails. After that, I'll print total locks. Whatever total locks are present here, that would be printed. Total stocks also same and total barrels also same. After printing these values, now I'll calculate the total sales. Okay, lock sales is equal to lock price into total locks. So we are taking the lock price of each lock and multiplying it with total locks to get the lock sales. It goes the same for stock sales and barrel sales also. After finding lock, stock, barrel sales, I'll add up all those. That is, I'll write sales is equal to lock sales plus stock sales plus barrel sales. And I'll print the sales as total stock as output. After this, we come to the main part, the commission part. So if the sales is beyond 1,800, then I should take commission as 0.10 into 1,000, that is 10% initially. Along with that, I'll take 15% and then 20%. But I have to minus these 2,800 should be deducted. Coming to this part, if sales is greater than 1,000, then the commission would be 15%. And else, if it is if these two conditions fail, then the commission would be just 1,000 just 10% of the sales. Then we are ending the if parts and finally giving the output as commission and commission. So this was about commission problem. This may not be asked in exam. Let's move further. We have the SATM. This could be asked for 5 marks. So we have to, there's no program here. We have to just explain how SATM works and what is it all about. Okay. So here we have SATM, full form as Simple Automatic Teller Machine System. So this is used to communicate the bank customers with bank customers via this screen. So this screen depicts 15 different terminals. Okay. This terminal depicts 15 different screens. So let's look into those screens one by one. So the first screen is welcome and insert the ATM card. So first screen says that welcome, insert the ATM card. Once we insert the ATM card, they'll ask us to enter the PIN. That is the second screen. After that, it will check if the PIN is correct or not. If it is not correct, the value is the output printed is your PIN is incorrect, try again. Now after I tried again, if again it fails, then invalid identification card will be remained, call the bank. So there'll be certain attempts, right? Beyond 3 attempts I cannot enter the PIN or something. So in those conditions the card would get blocked and we have to call the bank to retrieve our card further. So coming to next fifth screen, that is after once our PIN is correct, we'll land up to this page, that is the fifth screen, that is select the transaction type. Is it a are we checking the balance, or is it a deposit, or we are withdrawing any money? After that we'll select the account, either be it a savings account or any other account for that matter. Okay, after this we'll enter the amount. So whichever amount we have to take out from withdraw should be in increments of $10. So it has to be, if I want $50, then it has to be in increments of $10, 10 5 times. Then I have machine cannot dispense amount, try again. So there has to be certain limit, there will be certain limit for the machine, or depending on the balance present in the machine, the amount balance present in the machine, at times the machine may not load whatever amount I request for. In those conditions, machine cannot dispense amount, try again. Now second I'll see insufficient funds, please enter a new account. This appears when in my account if I have 10 rupees and I'm trying to withdraw 100 rupees. That's when this condition occurs. Temporarily unable to process the withdrawals. So when these two fail, when I'm trying again, it will come as temporarily unable to process the withdrawals. Then we can say once we take out the money, your balance is being updated, please take the cash. So this is at this 11th screen. Coming to 12th screen, unable to process the request. That is, if this fails, then we put the, if we have to deposit, we put the envelope in deposit slot and the new balance is printed on our receipt. And finally 15th screen is please take your receipt and ATM card, thank you. So these the SATM machine indicates how the transactions work, how actually how do we interact, what are the steps, what is the flow of interaction between a user and a system. Okay, next moving on further, currency converter. This could be asked for 5 marks. We have to draw the diagram and explain it. So here we have the currency converter diagram, which comprises of US dollars, and after entering the US dollars, we have to select which country's equivalent money are we trying to convert it anta. So after selecting these, we have to we can press compute, or we can press clear, or we can press quit. Compute is used to compute to convert the currency. Clear is used to clear whatever the value is present, and quit is used to end the one cycle of execution. So this was about currency converter problem. Then we have the Saturn windshield wiper problem or controller. So the windshield on some Saturn automobiles is controlled by a lever. So this lever has a dial. Okay, we rotate the dial, right? So here the lever has 4 conditions. One is off, then low, high, and 1, 2, 3 intermediate. Okay, 3 intermediate ones. Then in dial we have either 1, 2, or 3. So if the lever is in 0, if the dial is not rotated, then the wiper would be at 0th position. So if I increase the speed, if I make it to 1, then it would be 4. Okay. Next, if I increase the speed again, that is this 4 represents the windshield wiper speed. Okay, that is wipes per minute for lever and dial position. If I increase the dial, if it comes to 6, again the speed is increasing. Again, if I turn the dial to 3, that is the maximum it has reached in the intermediate range, and we'll get 12. Next, again I have low and then it will come to 30, and high means it will come to 60. So this was about the windshield wiper controller problem. So I would say that the triangle problem, the structural and the other representation is pretty important, and from this module it could be asked for 10 marks. And besides that, we have gone through all the theory stuff, right? Functional, structural testing, what is the importance and all of that. So stay tuned guys, I'll be uploading second, third, fourth, fifth module pretty soon. If you have any doubts, do let me know in the comments, and subscribe to my channel. Thank you.